In this video, we are going to start our discussion about different sampling methods, and we're going to discuss convenience sampling. So let's get started. So as we've talked about in the past with populations and samples, we use samples when we want to, of populations when we want to gather data for a couple of reasons. Reason number one being a population might be too large to get data on everybody. Reason number two, it might not be easy to get information from everybody, which is where convenience sampling comes in. Convenience sampling is when you just ask the people nearest you. Like, so for instance, if I just asked, the people in the top row of my Zoom or in the front row of my class, or if I step out into the hallway and just ask the kids who are in front of my door a question, that is convenient. I am asking the people who are closest to me. So it's easy and it does not cost any money because you're not spending money to collect data other ways. However, the problem with convenience sampling is that it is not always representative. So I have my researcher here and he is researching a question. Maybe it's something to do with the school as a whole. And as you can see, we have different types of people here. We have purple, we have green, and we have blue. Maybe the blue is teachers, maybe the purple is high school students, and maybe the green is middle school students. If this researcher asks the question to the 4 students who are closest to him, we see that he has 3 middle school students and a teacher, but no high school students. So that is what a drawback of a convenience sample might be, is that it is not always representative. For instance, in this case here, we missed the purple population or the high school students in our, kind of scenario. So that is not such a great thing about convenience sampling. All right, so let's take a look at these 3 different things about gathering ways of gathering data and decide if it is a convenient sample or not. So if you put an ad in a school paper for a project and you accept the first 10 students to volunteer, that would be a convenient sample because you're not really doing much work. You're just saying, hey, come take a survey, and you don't have to do any of the work. The volunteers are coming to you. So that would be a convenient sample. It is convenient for you because the volunteers are going to you. For B, you put the names of all the students in a hat and pull them out at random. That would not be a convenience sample because you're putting in the work there. You're writing all the names, you're pulling them out. That's not just asking people who are near you. That is putting in the work. That's what's going to be called a random sample, which we're going to talk about in a couple of days. You choose the 10 first students you see. That is absolutely a convenient sample because you're just choosing who's close to you. Like if I just walk out in the hallway and I ask the first 10 students at their lockers near my classroom, it's convenient and they're near you. So, all right, so this was a yes, a no, and a yes. And as you can see, our explanations are up here. All righty, let's move on. So suppose you're doing a research students on a project on the students in your grade, which is not an instance of convenient sampling. So let's go through each of these. You choose the first 20 students that you see. Yes, that is a convenient sample. You choose all of the students in your school band. That is convenient because if you are in the school band, that means you're in a band room with all of those students. They are near you and it's easy to get information from them. You choose all of the students in your classroom. That's just like choosing all the students in the band with you. Yes, they're near you. It's convenient. You choose 10 students from each classroom. That is not convenient. That means you have to go to each classroom and pick 10 students. Ain't nobody got time for that. That is not convenient. You are putting in the work. All right, let's take a look. All right, suppose you are a news reporter investigating the town's opinion on a new shopping center. What are 3 ways you could choose to convenience sample, and would they be representative? So let's say we take a sample number 1 and we ask the people in our neighborhood near the new shopping center. The sample would be representative because it's people in the neighborhood and they'd be mixed around. You have older people, younger people, kids, adults, different genders, males, females, all of that different stuff. All right, convenient sample. So again, people in your neighborhood, the people near you. That would be convenient and it would be representative. Convenient sample number 2, ask the shoppers in the new shopping center. That would not be representative because the people in the shopping center probably like the new mall. So they don't represent the population. If they're at the mall, chances are they like the mall. That's going to lead towards a biased response. And say we ask the people commuting to work on the street, would be representative because the people of the street would be a good mix of the population. However, in my opinion, that would also lead to a bias sample because if the new mall is creating more traffic, they might have feelings about that if they have to go through that traffic every day. So just keep that in mind. So yes, so they would be representative, but they also might create some kind of bias. All right, and last but not least, if you do a convenience sample on a highway to figure out how many cars are red, and you figure out that there are 16 red cars out of 40 in your convenience sample, the cars around you, how many of the 1,165 cars would be, if we estimate, how many of the 1,165 cars would be red? Well, first thing we need to do is we need to figure out how would we go from 40 to 1,165. So let's do a little division here. 40 would fit into 116 twice, and you'd get 80. Subtract, you get 36. Bring down a 5. 40 would fit into 365 9 times. You get 360. Subtract, you get 5. Add a decimal. Bring down a 0. 40 would fit into 51. It's 40 times 1 is 40, and so on. So it would be about, multiplied by about 29. About 29. So 9 times 6 would be 54. 9 times 1 is 9, plus 5 is 14. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. 4, 6. So it would say, based on our estimate, we can estimate that there would be about 460 red cars out of the 1165. Now the second question, is your estimate accurate? Well, we don't really know. I mean, if we only are sampling 40 cars out of over 1,000, so that's a pretty small percent of the cars. So chances are that might not be the most accurate estimate. We might want a larger sample next time. Alrighty, so we are going to stop here and we will discuss more of this soon. Bye, guys.